Hey guys, this is Miss Corey and I'm a resident at Sally Umbo Elementary in 3rd grade math. So today we're going to be looking in Module 6 at Lesson 1 and we're going to generate and organize data. So I'd love for you to read our objective with me today. All right, I can generate and organize data. So we know when we start our math lessons we want to start with our fluency. So go ahead and get out your pencil and paper. And I want you to draw this number line for me. Draw this number line. And so we know we're starting at 0 and 60. And we've got some of our tick marks already marked, but there's some blank ones too. So our first question says, what is halfway between 0 and 12? Okay, so that should be pretty easy. We want to half 12. So we know that 12 divided by 2 is 6, or 2 times 6 equals 12. So I know that I can put 6 in between my 0 and 12. So if I'm going from 0 to 6, then I am going to skip count by 6s. So we need to fill in our missing hash marks or our tick marks, and we're going to count by 6s to 60. So count with me. 0, 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. And so we know whenever we're looking at this that we can move up or we can move down. And when we move up, we're adding 6. When we move down, we would subtract. And so this looks a lot like maybe a thermometer that you've seen in science class. So let's move on. And I want you to draw me this number line. It looks like our number lines. And so we're going to start at 0 and end at 70. And we've got our tick marks. And look, they've only done us one favor. We only know 14. And so we need to know what is halfway between 0 and 14. So once again, we're going to take half of 14. So 14 divided by 2 is 7. Good. And so 2 times 7 is 14. So I know that that is 7. So if we know that it's 0 to 7, then we're going to skip count by 7s. And we're going to fill in our missing hash marks. So let's count by 7s to 70. Make sure you're counting with me. 0, 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. All right, so that's our skip counting by 7s to 70. So let's move on to a different part of our fluency. I want you to draw me this rectangle. Draw this rectangle, and we see that there's a 6 above our rectangle. So what is the value of the whole? Well, I'm thinking it's 6 that's above our rectangle. So let's look. They've drawn a line in the middle of our rectangle. So we have broken apart our rectangle into how many equal parts? 2 equal parts. So we know that it is broken apart into 2 equal parts. And our whole is 6. Just like at the top of our rectangle. So now I need to know a division problem to solve for the unknown group size. So when we're talking about division and we're writing a division equation or a division problem, we're going to start with our total, which is also the value of the whole. So our total is 6 divided by, all right, how many equal parts did we break our rectangle into? 2. So 6 divided by 2 equals 3. All right, so this is easy. We can do this quickly. So I want you to move on. And look at this. I want you to draw a rectangle. And I want you to draw 8, or write 8 at the top of your rectangle. Just like you saw in that last one, I want you to do that on your paper. I'll give you a minute. All right, and then as you do that, I want you to divide it into 4 equal parts. So we've got a rectangle, We've written the whole as 8, and now you're dividing it into 4 equal parts. If we're dividing it into 4 equal parts, how many lines do I need to draw inside my rectangle? 3 lines. Good. You can also half your rectangle and then half those in half. All right, so I need another division equation to solve for the unknown. So I know I'm going to use my total divided by how many equal parts? 4 equals 2. So I know that I can label the value of this as 2. 2 units inside each equal part. All right, awesome job, guys, and let's get ready to start our application problem. So that means you can take out your math journal or just continue to write on your piece of paper. Awesome job.
All right, boys and girls, I'm Miss Williamson from J.S. Clark Magnet School. And if you look at our next slide, you're going to see our application problem that we do in class every day. And one of the strategies that we've used all year long is the RDW strategy. So let's start out and let's read the problem first. Damien folds a paper strip into 6 equal parts. He shades 5 of the equal parts and then cuts off 2 shaded parts. Explain your thinking about what fraction is unshaded. So we've read our problem. Now we need to draw. And I already have a rectangle drawn for you, but we're going to take our paper strip and we're going to fold like they ask us to. Now to make 6 equal parts, this will be our whole. And then we're going to fold it into thirds. So we're going to come over and fold about halfway or a little more than half, and then fold again. And as long as your edges are tight and lined up for your equal parts, you can pinch those folds and then open up your strip. If I can get it open here. Well, so we have our thirds. Now we're going to fold it one more time, and that should give us our 6th. And we will have 6 equal parts. So you can see that where my creases are, I have 6 equal parts. Now, my unit fraction for each equal part would be 1/6. Now, in our problem, it says that he cuts off 2 of the shaded fractions. But before we do that, let's shade in 5 parts of our rectangle. Now, who can tell me how much of this rectangle is shaded? What fractional part of this rectangle is shaded? Yes, you're right, 5/6. Now, what part is not shaded? Let's go ahead and specify. And yes, 1/6 is not shaded. Now, if we X out or we cut off 2 of the parts, who can tell me now how many 6ths I have shaded? Yes, you're right, 3/6. And we still just have 1/6 not shaded. Now, boys and girls, I know that a common mistake that we make is that once we cut off or X'd out these 6, some of you may have seen 4ths now. But remember, we started our whole with 6 parts. So our denominator did not change.
Hey boys and girls, this is Ms. Voorhees from Sally Humble. I teach 3rd grade math. And today I'm going to talk to you about our concept development portion of our lesson. So we're going to move to the next slide. Okay. One efficient way to collect and organize data is to use a tally chart. One tally mark looks like this. That's one line that represents 1 or 1 vote. Each tally, like the one I drew, has a value of 1 student, so count with me. 1. So the more tally marks I draw, the more students each one will represent. This is how 5 tally marks is represented. 1, 2, 3, 4. And who knows what to do when I get to the 5th tally mark? I cross it over like a slash. That way it's easy to count by 5s when I'm counting many students. What I like to do normally is poll my class for their favorite color. And since we don't actually have students here, I'm just going to make up some different numbers to go on our tally chart. So the colors we're going to talk about today are green, yellow, blue, and orange. Green, yellow, red, blue, and orange. So I have some fake votes for each color. So let's say 6 students voted for green. 4 students vote for yellow. 8 students vote for red. 9 students vote for blue. And only 1 student votes for orange. For some reason, orange doesn't always get that many votes. So I'm going to make tally marks in our chart for each student. So for green, 6 tally marks would look like this. 1, 2, 3, 4. I cross over on 5, 6. I'm going to draw 4 for yellow. 1, 2, 3, 4. For red, I'm going to draw 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to draw 9 for blue. 1, 2, 3, 4, 5, 6, 7, 8, 9. And for orange, we only had 1 vote, so we're just going to draw 1 tally mark. It's easy to see how many votes each one got because the more tally marks, that means more votes. So that's one way to show organized data. I'm going to use the same data on the bottom for my picture graph. So I'm going to use the same votes. I'm just going to redraw it using a picture graph. So for green, we had 6 votes. For yellow, 4 votes. For red, 8 votes. For blue, 9 votes. And for orange, we had only 1 vote. Now, it's important in a picture graph to always look at the key or to make a key. Here, we're going to use a heart for votes. Sometimes a heart can represent only 1 vote. Sometimes it can represent multiple votes, like 2, 3, 4, 5, whatever you decide. So we're going to say that our heart represents 2 votes because it'll take us less time. So for green, if we had 6 votes, I would draw 1 heart, which represents 2. So I'm going to count by 2s. 2, 4, 6. For yellow, we had 4 votes. So I'm going to count by 2s since each heart represents 2. 2, 4. For red, we had 8 votes. So I'm going to count by 2s. 2, 4, 6, 8. All right, for blue, we had 9 votes. So let's count by 2s. 2, 4, 6, 8. Well, if I draw another heart, that'll be 10, and that's too many. So how can I make 1 vote out of a heart? Well, what I would do is draw half of a heart. Like that. So 2, 4, 6, 8, and half a heart is 1, so that makes 9. Okay, and last we have orange, which had 1 vote. So we know when we need just 1, we're only going to draw half of a heart to represent 1 vote. And that's how you organize data using a tally chart and a picture graph.
Hello, boys and girls. This is Miss Heisler from Sally Humble. I'm a resident in 3rd grade math. Now let's go ahead and move on to our student debrief. Since we've already learned from Miss Voorhees how to organize data on a tally chart and a picture graph, I want to know, how are they similar? How is a tally chart and a picture graph similar? I'll give you a minute to think about it. All right, so whenever we're talking about earlier in our picture graph, let's go ahead and look at it. Even though they look different, they are still showing the same data. So that is a way that they are similar. Now let's talk about how are they different. Think about how these two graphs are different. So in our tally chart, we're using tallies. And in our picture graph, we're using shapes. In this case, we're using a heart. In the other cases, you might use a square, a circle, whatever you choose to use in your picture graph. But even though they're showing different, they look different, they're still showing the same data. The next question says, how does a tally chart help you record and organize data? When we're using tally charts, we use one tally for each student or whatever we're counting by. So if we're using 5, we have that easy slash, and that's so easy to see when you're counting by 5s. And we all know 5s are very easy to count by. So that makes it very easy to organize data when you're talking about a greater amount of things. Why is it important to understand the value of a unit in a picture graph? So when we're talking about our key, why is that key so important? If we did not know the value of each unit or each picture, then we wouldn't know what we're counting by. In this case, we're counting by 2s, but if we did not have our key, we wouldn't know. We would probably just count by 1s. So it's so important to look at your key whenever you're looking at a picture graph, so you'll know you get the right answer. It's so good to see y'all guys. I hope y'all have a great day. Bye.